Hello everyone. Today I am going to present one IEEE paper that is published in Communication Letter. Topic name is User Selection in Reconfigurable Intelligent Surface Assisted Communication System. With the commercialization of 5G mobile network, the quest for enabling technology for the next generation mobile system is currently underway. Reconfigurable intelligent surfaces, which consists of large number of low-cost and passive reflecting elements, each of which can be independently reflect the incident electromagnetic waves with adjustable phase shift, have recently emerged as a promising candidate due to its desirable feature of low energy consumption and high spectral efficiency. And next is, hence the RIS assisted communication have received considerable attention from both the academia and industry. In 5 to 7, by assuming the perfect channel state information, that is, its means abstract is CSI, the optimal phase shift design of RIS assisted communication system are studied. Later on, robust design in the presence of imperfect CSI is pursued in 8 to 11. The fundamental performance of RIS assisted single antenna system is studied in 12, while the extension to the multiple antenna system is given in 13. Here RIS means that RIS surface is consists of single antenna in the 12, and in the 13 RIS surface is made of number of antenna system, that is array. The integration of RIS with various transmission technique has been considered, including millimeter wave in 14 and 15, two-way communication in 16, and simultaneous wireless information and power transfer in 17. While the above mentioned work have greatly improved the understanding of performance of RIS assisted communication, the impact of the multi-user shielding remains unclear. Responding to this, a detailed investigation on the performance of RIS assisted communication system with user shielding and characterize the achievable multi-user diversity gain is provided in this paper. Specifically, two different scenarios are considered. One is without CSI and other one is with CSI. For both the cases, analytical expression for the ergodic capacity of the system is presented, based on which asymptotic analysis is conducted to reveal the impact of the key system parameters. A RIS assisted wireless communication system consists of one base station. You can see here one base station. This one is the RIS surface, and here is number of user that is numbered from 1 is called user 1, user 2 and up to k. So there are m number of user, and this is made of n number of antenna array, and that is a total number of element is n, and that is n cross nc. Since the RIS is likely to be deployed at the position where exists line of sight path to both the base station and user, Radiation distribution can be used to model the channel. So for Radiation distribution, the channels are H0 and Hi, and H0 is for base station to RIS, that is, and RIS to ith user is channel is denoted by this Hi. Here K0 and K1 are the radiation K factor of H0 and Hi. Alpha naught and alpha I are the largest scale path coefficient. H0 is from the channel 1 means channel n cross, that is n cross 1 matrix, and Hi that are the means H0 bar and Hi bar is the line of sight component. H0 tilde and this Hi tilde are the non line of sight component whose elements are independently and identically distributed. Zero mean that has zero mean and unit variance. Since RIS has UPA, that uniform planar array, then the line of sight component H0 bar and Hi bar can be expressed as. So these are the like array factor for from base station to the user and user to the base station to the RIS and RIS to the user. So this H0 bar and Hi bar has been given, and this is the AN for the antenna element, that is for the uniform planar array, and this can be considered as array factor. Since the user is likely to be blocked from the base station, we consider two cases. One is Raysian fading, means ray light fading, and while the other is that there does not exist direct wave user to the base station. So this channel between base station and users can be considered like gi is equal to omega square root of beta I into gi tilde. So omega is equal to 0 means there is no direct link, while omega is equal to 1 implies the existence of direct link. The elements gi tilde means it is from the channel are IID complex Gaussian distribution with 0 mean and unit variance like previous slide, and beta I capture the path loss of the channel between the base station and IS user. We can assume that users are clustered in a small area, and thus the distance between the reference paper can be found on this, means thus the distance between the different users and RIS can be assumed to be d1. So d1 is the distance between the user and RIS, and distance between user and base station is d2. The large scale path loss can be modeled as a function of distance, and thus we can assume that alpha is equal to alpha 1, beta is equal, these are the assumption, and beta is equal to beta 1 for all the users. This alpha is equal to alpha 1, beta is equal to beta 1 has been assumed. So where means alpha naught can be defined as alpha naught is equal to phi by d naught L, and here d naught d1 are the distance from base station to the RIS, d naught and d1 is from the RIS to the user, and d2 is the base station to the user. L denote the path loss exponent, and phi represent the path loss normalization factor. It is now system model, means each by I, that is each means signal is received by ith user, and now this is the capacity analysis. So here means all the capacity without the CSI and with the channel state information has been discussed. So the gain has been compared without CSI and with CSI. We assume that there exists a feedback link between base station and user, so the base station can schedule the user with the largest channel gain. Specifically, the kth user being scheduled, the ergodic capacity can be expressed as, so Ck is equal to E of log of 2 1 plus gamma naught into Ak, and gamma naught is the P by N naught. P is the transmitted power, and from the base station N naught is that noise, and Ak is the channel state information. This means both means line of sight and non line of sight component is added here, and the index k is determined according to the flowing creation, means k is the or maximum of this. So that will give the maximum, that will transfer, means this will contain the maximum, that will channel capacity will be maximum for this k. So in the flowing we consider two separate cases depending on the availability of CSI at RIS. So now here first we have discussed without CSI. When the RIS has no access to the CSI, we can assume that the phase phi n follow the uniform distribution. So here is one theorem: when there is no CSI at the RIS, the phase shifts are drawn from the uniform distribution. Then the ergodic capacity of the system is upper bounded by this log of 2 1 plus gamma naught omega square beta 1 n alpha 1 alpha naught gamma plus ln m plus 1. M is the number of user and n is the